Hi everybody, my name is Chris Ward and I'm one of the product managers for the Control Product business, and in this video I intend to demonstrate how to set the 3RW52 up and talk about a little bit about its functionality and some of the terminals and how you connect them. So hopefully you'll find the video useful. So with regards to the 3RW52, you can integrate it with either a basic HMI or an advanced HMI. So it could give you a look like the soft starter, which is on the main screen here. That is in fact the 3RW55. But if you integrated an optionary HMI into the device, they'll look very similar. To gain access to the potentiometers, which are shown on the front of some of the soft starters, you actually have to open this flap up to gain access to the configuration of the device. So 3RW52, to be able to parameterize it, you have to open this flap up and to gain access to the pots, which are very similar to the 3RW50 and the 3RW40. So this next slide just gives you a bit of an idea as to some of the bells and whistles which are on the unit. So number 1 and number 2, that's your in-feed in from your supply. Number 11 is your feed out of the supply. This is the seal. Here you've got a diagnostics display. Number 12 is the pin assignment. Number 13 is the conduit for the cables to be run through to these terminals. Over here, number 2, you've got a slot for a HMI screen. As I mentioned earlier, and we'll have a little bit of a discussion about that later, you do have the option to either have a basic HMI or a standard HMI fitted into this slot here. Number 3, this is where you plug the ribbon cable that connects the HMI. Number 4, these are the potentiometers which are used to parameterize the device itself. So in there you have a pot for the overload, the operational current of the motor, a ramp up time, current limit function, starting voltage, and a ramp down function. Number 6, this is where you can actually have an integrated communication module. So those communication modules can vary from Ethernet, Profinet, Modbus, and Profibus. Over here, number 7 gives you a description of the types of materials that you can actually connect into the soft starter and what sizes of cable that you might want to use. Here, it gives you an indication of the configuration of the device. The 3RW52, as you can see from the configuration which is there, 1, 2, 3, that's 3-phase control because you've got 2 anti-parallel thyristors with a mechanical bypass demonstrated on each of the phases. So if it was a 2-phase device, this middle phase would be a straight through connection, but it's not. It's a 3-phase control device, which means it can handle more RDS loads. This graphical representation on the left hand side here, this gives you an idea as to what you're setting the current rating to on the operational current. So rather than having each current individually set, on here what you have is a number variation from 1 to 16, and each number reflects a different amperage, and this graphical representation helps you to decipher that. So into the terminal configuration. So the terminal configuration, we had a little look at this one, which is fairly straightforward. So number 1 and number 2. Number 1 is your in-feed supply, so your 3 phases going in and coming out going out to the motor. You've got your 3 phases going out to the motor as well. Down this left-hand side, so you can have here will be a piece of a plastic strip which you can remove, which allows you to run your cables through into each of these connections. So you can remove that plastic panel off and then run all your cables through this plastic conduit, and then connect all your terminals to all your terminals. So T22, T12, and T11. There for thermistor sensors, you can either have a thermistor, or you can have a thermoclick. Or if you choose to have it, you can actually have that rather than thermistors dependent on whether you've selected thermistor or analog, you can have that as an analog output as well. So you can measure with an external device, whether that's an ammeter or a voltmeter as well. So there's an option dependent on which part number you select. You can either have a thermistor on this terminal, thermoclick or PTC, or an analog output. This next configuration here is a normally open, normally closed changeover contact. This effectively signals whether the device is in fault or in warning. So if there's something awry with the soft starter, with this changeover contact, you can send a signal to an external signal to either PLC or even an illuminated push button. It's just another way of signaling to an engineer that there's something incorrect going on with the device, or one of the parameters which you've assigned in the soft starter might have been breached. There's another signaling contact here. This is mainly for the arrangement of the device. So 23, 14 and 13, they're signaling contacts. So when you initiate a start, the device will enter the on mode, and so this can provide a signal to the user to tell you that an external signal that the device has been switched on. And then you have another signal here, 23 to 14, which will tell you when the device has entered bypass mode. So what do we mean by bypass mode? Bypass mode is when you've reached the full line voltage, the thyristors have finished switching, and then the device switches over to the mechanical bypass contact, hence bypassed. So this next terminal here, number 4, is the in signal. And this next contact here is the control voltage A1 and A2. So for the soft starter to actually start, you need to have a signal going to in, and you also have to have a control voltage. So without those two functions, you don't have a start. This next diagram shows the characteristics of the main circuit and also the control circuit. So in the main circuit, you always have a form of short circuit protection, which is shown here. That could either be a molded case circuit breaker, an air circuit breaker, a motor starter protector, or even fusing. So the standard protocol for a soft starter protection would be dependent on what type of short circuit that you want to achieve, whether you want type 1 or type 2 coordination. This demonstrates type 1 coordination with a motor starter protector. If you wanted type 2, that's typically done with fusing. Now, as you can see here, downstream of your short circuit protection, you have the soft starter, and then you have the motor starter, and the motor is typically earthed, not the soft starter. Whereas previously on the older versions of soft starter, you could earth the soft starter, whereas now it's all handled through the motor. So in a typical mains feed configuration, you'd have short circuit protection, soft starter, and then your motor, which is earthed. To wire the device in the control circuit, as you can see here, you've got your A1 and your A2 terminals, and you've also got your in signal. And that's all you need to start the soft starter really. S1 is to start the motor, S2 is to turn the motor off. So if we was to initiate a start here, we press S1. The S2 circuit here, as you can see, is already continuous. So as soon as S1 is pressed, you already have your control voltage supplied, so the motor would initiate a start. If you was to break that circuit with S4, which is the stop command, that would immediately bring the motor to a standstill through a coast. If there was a fault, say for example you had an overload condition, or perhaps you had an error integrated into the soft starter, or a malfunction, what you have to do is you have to rectify the fault, and then you have to acknowledge it here with a reset. So you have to keep the reset button pressed in for up to 3 seconds, and if you don't, you won't be able to initiate a start with S1 and the fault won't clear. with that reset command. Another way that you can reset the 3RW52 would be to hold in the test and the reset button for 3 seconds on the front of the unit. And then lastly, we have, as you can see here, the changeover contact, which shows faults and warnings. That's not been connected in here, but if you want to, you can wire an external signaling device. Further to that, as you can see here, this isn't actually essential, but we have wired in the on signal. So that is just telling us that the device has been switched on through an external signal. So one of the really great features of programming with a 3RW52 is that you can actually integrate these option HMIs. So this is the basic HMI and this is the advanced HMI. So the reason why you'd use one of these is it's really quick and it's easy to be able to identify faults with. They are an extra cost, but in terms of the time consumption which is made by identifying faults sometimes in wiring and how you've programmed the device, it can be quite time consuming because you have to depict how the lights are flashing on the front of the unit, which isn't always easy, because there's different colours that the lights can go into, and they can either flash intermittently or stay on, and each individual light sequence can mean an individual fault, whereas if you're using one of these HMIs, you don't have to decipher that information. It'll give you an error code on this one, or it'll give you a texted line display of what the error is on the more advanced HMI. So I would recommend highly that you would use either a basic or an advanced HMI. At least purchase one of these for commissioning your soft starters. You can swap that and take it with you into each of the soft starters that you're programming. You don't have to keep it in one device. You can constantly use it in each of the devices which you're commissioning. But just to make things easier for fault identification purposes, using one of these HMIs is a godsend. So how do you commission and how do you parameterize the device? So my main tip for being able to do this is you'll install the device as we just looked at on the previous slide, and you'll connect the device as we discussed on the previous slide, and then you need to parameterize the potentiometers. So the potentiometers for the device are the operational current, which you can get on the nameplate of the motor, the overload protection, which you can get, which would be depicted by the nature of your application. So how long would it take for the motor to start? If it takes less than 10 seconds, you select class 10. If it's up to 20 seconds, class 20, and so on. So the next potentiometer which you could select is the ramp up time, so how long is it going to take to ramp up, and the starting voltage. What starting voltage do we want the soft starter to ramp up from? Say for example, if we had a circuit which was at 400 volts and we initiated a start at 50% of the starting voltage, it would start the motor at 200 volts, and then dependent on the ramp up time that we set, it would take that time to ramp up to the full load voltage of 400 volts. So it would increment from 200 volts. Say if we set a ramp up time of 10 seconds, it would take roughly 10 seconds to reach from 200 volts up to the full line voltage of 400 volts. And then the final voltage parameter would be the ramp down function. So with the ramp down function, you would set a time for the amount of time you want that to coast down to 0. And that can be, we could set that potentiometer from anywhere from 0 to 20 seconds. And then the final potentiometer is the current limitation function. So the current limit function won't allow you to go above a certain current rating during the startup. So if you did go or get towards the threshold of the current which you've set for the maximum capacity during the startup, the voltage parameter that you've set will be overridden by the current limit function, so it won't go off the time that you've set in the ramp up time. It'll regulate the current until it reaches full speed by regulating the current instead of using the voltage ramp. So you do have to be careful with that as well, because if you set the current limitation function too low and the ramp up time has elapsed and you haven't actually reached full speed of the motor by the time it reaches that ramp up time, it'll enter bypass mode and the device will go into fault and it won't initiate the start. And once you've done that, then you can perform a test by starting and stopping the motor, and then just to ensure that the device is operating correctly, and then you can use a seal if you wish to. But to gain an understanding of those parameters, I just want to show you another slide here, which is really useful. So if you haven't seen this already, it's the Siemens STS tool. In the STS tool, you can fill in the parameters for the environment and the supply, the motor and the load. And once you've done that, you can then start finely tuning the parameters. So here it allows you to simulate the application. So we can choose the application. We might have a pump application. And then we can say, right, okay, well, what do we need to set these parameters to? Well, we know we can set the parameter to 3 times the rated current here. If we wanted, so that's the starting current limitation function, so the current limit function can be set to 3. We'll turn that off. Well, what can we set the starting voltage to? Oh, well, we know we can get away with setting it at 70%, and the ramp up time we can set to 5. So what we're doing here is we're simulating the application and gaining an understanding of the application parameters before we've even purchased the unit. So there's no trial and error to see whether the motor is going to start beforehand, because you've already simulated the application virtually with this tool. So it is a free download off the Siemens Technical Support website. And if you need any assistance in using this tool, please refer back to my previous video on how to program by using the STS tool and how to simulate an application. So I hope you found the video useful. Please stay tuned for more videos. Thank you.